Welcome to the November webinar of our GoldSim webinar series for 2024. I'm thinking this is the second to last webinar of the year, and we'll probably be doing one next month. But this one I came up with just recently because there have been some recent questions about this, and also I've come up with a solution for one of the ways to deal with missing information in time series records that I wanted to share with you. And then there's also a couple of other things that I'll go into that were also asked of us by some users. So first of all, before I get into ways of dealing with missing values from your time series records that you're going to be using in GoldSim, we need to talk about just the time series element in general and how to work with it. It's important to understand the different properties. There are many different ways of representing data in a time series element. And then also, and on top of that, there's a lot of added functionality to the time series element that you may or may not be aware of. There's just a lot of functions that that you can make use of in that element. So it's important to review it and look at it. Then I'll go into simple interpolation, just some techniques to very quickly and easily represent the or deal with values that might be missing from your time series. It kind of depends on the context, but I'll go into some examples. But mostly I want to talk about imputation and a method to go about that, and show you some a working example. I think it's important, especially within GoldSim, because you can use stochastic imputation very quickly and very easily in GoldSim. The next thing is I want to talk about is comparing discrete data to continuous time history. And so what I mean by that is sometimes you have measured sampled data that comes in at discrete points in time that are not regular. But your model is advancing forward in time on a regular basis. So there are tricks to better visualize the two together that I want to talk about. Okay, so I'm just going to walk through briefly some of the main types of time series within GoldSim, but I need to cancel out of this presentation before I get started on this, just to briefly review the time series element. So let me do that. Okay, so here's a GoldSim model, and probably be best if I minimize some things in the background here to just make things less busy and complicated. Okay, so in GoldSim, the time series element looks like this when you open it. These are all the properties here. The one I'll be focusing on a lot here right now is this represents property. But let's just go through these. So first of all, on the display units, let's talk about this just for a second. When you're working with daily data that might be in terms of might be a rate, like a flow rate or maybe a precipitation rate or something like that, then it works fine on a daily basis to say something like, you know, length per time like this per day. That works well because every day is the same as far as length of time. However, when you're working with monthly data, just be really careful here. You want to avoid saying per month and when I say month, I'm talking about the unit of time right here, MON, month. This unit, this is a dimensional unit that represents the average month of an average year. So that is a constant. All of these units represent constants. So this is a common point of confusion to people when they're entering this MON unit. This represents a constant. So how can it be a constant if our calendar does not have months with the constant duration, right? Well, we do an average. So the MON here would be 30.4375 days. So if you were saying millimeters per MON and you were looking at February, then you would have to, you know, scale it appropriately, and that's a big pain to do that. There are much better ways to deal with monthly data. So keep that in mind. Also note that a time series does not have to be just one, it doesn't have to represent just one thing. You could have it be a vector or even a matrix, as you can see here. So if you make the time series a vector, then what you'll see is multiple points in time still like you always do, but instead of having just one column of data, you'll have multiple columns of data for a vector. But just keep in mind that with a time series element, it's a little different than all of our other elements in that it always has in this dimension going down, I call it a dimension, but it's not really a dimension in terms of like a matrix or a vector, but it always has time going down the rows. So that means if we go to a vector, we have no choice but to go across columns to represent the vector. And then if you go to matrix, then you got to work with layers. So that's a pretty big piece of data set if you're working with a matrix time series. So, but just keep in mind, you can do that. The next thing is the data source. I won't be working with any of this today, but just know that you can get your data from various locations. Okay, the next one is represent. So this is what I want to talk about here. When you click on this, you'll see there's all these different options, and it really just depends on what you're trying to represent. What is the data representing? If you are, for example, gathering data from a totalizer, like a flow, like a flow gauge on a pipe that's totalizing. So it's saying there's this much volume that passed by and it keeps accumulating over time. Then you might say, oh, okay, then I'm actually going to want to represent how much it changed over time. So you might say that, or you might say I'm actually wanting to get the instantaneous value. But usually what we're going to be talking about in those types of cases when it's totals is that you would want to look at the rate of change output. We'll talk about that in a second. But just keep in mind that we have different ways of representing these. The main two different ones are these first two. The instantaneous value is going to allow you to interpolate linear between times in your time series. And then a constant would be, staying constant. And so let me show you some pictures of what that would mean. So when we say instantaneous, typically you would use instantaneous for something like flows or temperatures, for example, because usually if you have smaller times in a place where you have smaller time steps, then an interpolation between the 2 points kind of makes sense in those cases, probably. So in points where you might be missing records in a case like that, then an interpolation could work pretty well. It might not be exactly right, but it would be a pretty good approximation just by interpolating smoothly. Note also that if you output both the main output of the time series and the other output that's called rate of change, then you can see how these if you look at a plot of it, you'll see how they do correlate here. When the main output is constant, then rate of change is going to be 0, shown over here on the y2 axis, be 0. As soon as we start to draw the line, as soon as the line starts to drop downwards in a downward direction, then we have a negative rate of change and an even more negative change. And then when it starts going up, then you see we have a positive rate of change. So that's the rate of change output. And then compared to the main output, those are the two outputs that are coming from the time series element in the case of instantaneous when you pick that one. So just remember the instantaneous value, it's going to be connecting all of your points in your time series linearly. Then we have constant over next interval. So constant over next interval is just going to be kind of like stair steps. It's going to hold the value in your time series as you walk through time, despite however many, if you have time steps on each time step, then you'll have a stair step on each step of the way, but you might have a lot of time points that don't have information, and so it would just hold a constant value over that whole entire period that it doesn't until it changes next. And then if you plotted the rate of change in addition to that, you see that it only shows a change when the stair step occurs. So that's going to be quite a big difference there. Now in the case of that I was mentioning earlier, where you might have monthly data, like for example, monthly rainfall, for example, and you really want to use the data to represent a rate in your model. So maybe you're calculating runoff, for example. Then what you can do is you can say, well, let's just put in our time series as a cumulative, as an integral over time, like this red line is showing. So that'd be your cumulative monthly rainfall. You just put those, add those months up in maybe in Excel or something, put it into here, and then when you specify rate of change, GoldSim will know how much time has passed, over each calendar month, and do all the math for you and calculate the correct rate of change. So this is something not really centered on what my presentation is on, but kind of a side note here that if you are dealing with monthly values, this is a really good way to do it and specify the represents as a change over the previous interval. And the reason it might be previous interval instead of the next interval, you can do both, by the way, change over next or change over previous. Change over previous makes a lot of sense sometimes when you're dealing with totalizers because they are accumulating since the last update, right, until the next one. So that would be a change that's occurring over the previous. So it just depends on, right, how what the measured data represents. Okay, finally, another type of represents that you can use in a time series, and this is an important one, and it also will be covered in my discussion of the comparing of discrete versus continuous type of outputs. The discrete change type of represents is really powerful for when you don't have regular intervals in your time series. So that'd be a case where you have spot measurements at random points in time of whatever thing you're measuring. So for example, maybe you're measuring like a water level, and you're not measuring them at regular intervals, only at specific points in time, then you might want to use a discrete change, because then it will only specify or only output those values at those times instead of every single time point. This will kind of make a little more sense as I show you an example. And let's do that now. What I want to talk about now is how we deal with missing records using just a simple interpolation. So when we approach this kind of a problem, we need to kind of take in the context of what our data is. So let's say we're dealing with precipitation in an arid location. And in those cases, you might say, okay, most of the time it's not raining. And if that's the case, then you could make a fairly reasonable assumption that for any missing records, we're just going to say it's a 0. And that would be, maybe you could say, okay, that's conservative, right? I mean, maybe the gauge stops working when it rains. So that would be unfortunate. We would miss those points. But if you don't think that's a common situation, then you could just say, all right, anything that's missing, we're just going to assume that there's zeros. And if that's the case, that's a pretty simple thing to do in GoldSim, because that would mean all you would need to do is set up an cumulative time series that you could then just calculate the rate of change over time. So let me explain that. So here's a simple model, and in here I have this time series in which I have this value reported on this day, 11/29, but it turns out that prior to that day we had some missing records, so we don't know what happened just before that day. Okay, so that's an issue. That could be an issue. Next, we have another value here in which right after that day there's missing records. These are all things that are common, could be easily happening in your time series that you get. So what do we say? If we said this is a constant over the next, well, let's see what that looks like if we say constant over next. So we'll say it's an instantaneous. Oh, actually, let's start with instantaneous. Let's say we assume instantaneous value, and then just see what that looks like when we run the model. So I'll run this model and I'll plot this, and then what we see here is some pretty big problems. We had in our record only one day of a number of this rain occurring on this one day, but you can see that it is reporting, because we're missing time points in our time series, it's just linearly interpolating, right? So it's starting at 0 and just ramping its way up, causing us to have this huge amount of rain that we would accumulate in our model. That would be problematic. Similarly, on the other side, if we say, okay, there's this day we had rain and then we had missing records following it, then and it's going to linearly interpolate between those two. So if I go back to the table, then what you see here is that it's linearly ramping up until it hits the value that was recorded in the time series. Same thing on this one where we're missing values. It reports the value and then it slowly ramps down or linearly ramps down to 0 until we get to the next time point, which is 0. So we can say, okay, well, we don't like that, definitely don't like that. So we could, whoops, I'm so used to hitting the function keys on this keyboard. Okay, so just by the way, I'm always using F4 and F5 to run the model and go back to edit mode in case you missed that. So anyway, let's change this to constant over next. Run the model. And so now what we see is it makes sense for this one because in this one, it just turns out that on the 29th or on the very next day after the 29th, we had a record that says 0. So it just works, right? We would say it's constant over next, but the next day is 0. So this is exactly correct. But it's the next one that's the problem. On the next one, we said constant over next and we were missing records. So then we have this constant going on for a long time. Okay, so another approach that we can take is we can say, let's convert this time series to an integration. And so you can go, this is easily done in Excel. You can come in Excel and you can just take this data right here. This is the same data. So I can come over here and I can just say, let's just integrate, let's just add this record to our previously calculated record. And then just do that all the way down. And I'm doing it from the previous day to the current like this. So you'll see a slight delay here like this as we go down. This is problematic once again because you get down here to when we're missing records again, and you'll see that the jump is occurring over a 3-day period. So then we could say, okay, well, we don't really like that. Maybe what we could do is we could say, let's add the current day to the previous day. Let's see, is that what I want to do? Yeah, that's what I want to do. So you could say that, and then we get down to this point and we say, okay, we added that value on this day. We get down here, we added this value exactly on that day, and then we could put those in here. So you can see that's how they're in here. And then once those are in there, you could say enable rate of change output. And so then when you run the model, you'll get just those values at just those points when they change. Here's a plot. So this is correct as far as the amounts go. The only problem is that it's shifted forward. You can see it's shifted forward 1 day. So in here, you see that value was recorded on the 2nd, 12/2 and 11/29, and it's shifted forward to 11/28 and 12/1. So in the grand scheme of things, maybe that's okay. We've got a quick workaround in cases like this. This is a pretty quick workaround without having to do very much in Excel. But the reality is you probably want to fix it a little bit better than what we've done. I'm just telling you, this is a very quick workaround. It'll get you around these issues pretty quickly, but it is shifted forward. Okay, so, and there's probably there are some other things you could do, but these are some common ways to deal with that kind of stuff. But we still have problems here where we are missing records. We don't know what happened on those days. And so is it a correct assumption to say that it's 0 if there's no record there? In the case of sparse data or information that is commonly 0, and sometimes not, then it might be somewhat safe to say, well, if we don't have a record, let's just assume 0. So that would be a case for, like I said, precipitation in an arid location where the value is most commonly 0. Then you could say, well, if we're missing records, let's just say 0. In a case where you have temperature or something like that, where it's not commonly 0, then you're kind of stuck with saying, well, we could either just assume it's constant, it stays constant over the period, and sometimes that's a pretty safe assumption to make. Or you could say, let's just go ahead and linearly interpolate. So with temperature, that is a pretty good idea. Just linearly interpolate. As long as you're not missing too many values, then that could be a pretty close approximation to just do linear interpolation. And then there could be some others. But overall, we're still making some pretty broad assumptions that could introduce some error. Typically with time series records that you obtain that have few missing records overall relative to the number of total samples, it's not going to make a huge amount of difference which direction you go here overall. But if we want to be more accurate, or I should say more realistic, something we should consider is imputation. So let me go there now. Open up another model. Okay, so here's a model in which we have a long time series record. So here we are. It says it starts in year 1900. This is data that I downloaded from the National Weather Service. It's called I can't remember. Maybe if we have time at the end, I can point you to it. But you can download daily precipitation totals and temperature records, daily temperatures for many locations around the world. And this one is at a site called Australia Plains, Australia. And so as you go down, you can see here, here's pretty sparse records as I scroll down here, but there are places where we have errors. So there's an error code right here, -99. But importantly, we also have other problems of, let me go up just because I remembered this location. Here we go. So here's some missing days, and it's right before a fairly significant rainstorm. This is in inches per day, by the way. So that's a pretty sizable rainstorm that occurred. And so it's a little bit questionable right here of what we would do about these missing records from the 22nd and until the 29th. If we were to say they're just zeros, that would be questionable, right, with such a large storm occurring on this day. So in this case, in cases like this, you might find many situations like this in this model, and therefore we'd want to do something like imputation, and that would be where we could run a model that would do a prediction or a better prediction of what could have happened in those missing days. Okay, so somebody asked if I was talking about silo or long paddock, and I don't know exactly what you mean by that. Are those must be data repositories? The one I'm talking about is called National Weather Service. Oh, here we go. Anyway, we can get there. We can get there later. Okay, yeah, those are data repositories you're talking about. We can talk about those at the end if we have more time. It would be interesting to hear about some other location. I've been always going to one location for all this data. I've been finding quite a bit. So anyway, so here we have this data with some problems in it. And obviously, we want to put this into Excel and do some analysis, and that's what I've done here to get a look at it. And there are a couple of things that you'll want to always do when you work with data in GoldSim like this. When you get the data from online, oftentimes you'll get just blanks instead of having a value in here. So this column D. This was the actual data. Actually, all of these columns right here. This is the data that came from the web. And in this column D, there are places where we have blank entries. Those are problematic. We cannot deal with those in GoldSim. We can't have a blank. So then I created this extra column next to it that all I do is I say, okay, is this a number? And if it is, okay, let's use it. Otherwise, let's use an error code, negative whatever. I use a negative number because it makes it very clear when you're working in GoldSim that this is not a number we want to be working with. So I do that first, and then this is the column of data that I put into GoldSim so that it'll be accepted. But it's still problematic. It still has missing records, and it still has these negative 999s. So then what I did is I added another column, and this column I just called it DT. And what it does is it says, okay, I want to calculate. Actually, all we need is, we don't need -1. We could just do something like this. And what this does is it says how much time has elapsed between the two rows that we're looking at right here. If you can get that information, and that's pretty easy to do, you just say it's this minus this, and then just copy it down, and then you'll want to put that into GoldSim as well. So that's what I've done here, and it looks like I did that -1. Yeah, that's what I did. Oh yeah. I keep forgetting. I actually said this -1 because we're trying to capture how many missing days do we have as we walk down this. How many days are missing? That's really what I'm looking for. So I said it's that date minus this date -1. And so then once you have that record, then you can scroll down and then you'll see, okay, here's a 1 right here. And that's because we're missing May 27th right there. So now that I have this time series, I just go ahead and I put that in here too. And so then it just, as it goes down, it just looks for, it just points us to locations where we're missing. Let me see if I can get to 11. There it is. So here's this location I was pointing to before, where we're missing these 6 days. It's actually 5 days that are missing between these two dates. Okay, so so with that, I come in here and I have this logic that's a little bit confusing, but essentially what we do is we say, okay, do we have missing records? This thing tells us, yes, we have missing records. I also only want to trigger an event where we're looking at missing records if this value of the time series changes. And I don't want to bog down too much into all of the details of how I set this up. I will provide this model after I post the recording of this webinar, so you can have a look at it yourself. But essentially what we're doing is we're just catching those moments where we start to have a situation where we're missing a record. And that's right here. Right here is one of them. So it just, this element will just trigger an event as soon as that happens. As soon as it sees that, oh, we have missing records, it will trigger an event. And then what I do is I say, okay, well, that happened on the day that we have data, so we need to delay that 1 day. So I'm just shifting down 1 day and saying that's when the missing records begin. In this case, it would be May 27 would be the first missing record because I've delayed it by 1 day. So it says, okay, that's our delay. That's just delayed by 1 day. I delay my event. And then when that event occurs, we push that value, whatever that value is that we found here, whether it's a 6 or a 1 or whatever, we push that into this integrator. And we do that by using this instruction replace. So it just says, okay, whatever that was, just replace it. This is going to be the duration of our missing record time. And then what I do is I just, as we march forward in time, I reduce a day each day. And then it allows us to essentially capture only those moments where we're missing records. And in my case, I'm not only doing it there, I'm also doing it when we have, I'm also making sure that we're ignoring places where we have the error code of -99, because I'm dealing with that separately. This is just for missing records. So now we know, using this little piece of logic right here, now we know we've been able to capture those times where we're missing records. Now that we have that, now we can say, okay, let's do some imputation. Let's use a model to fill in the gaps during those missing times. And it turns out when you're dealing with precipitation, well, we have a Markov model in our library that is a very simple, clean way to simulate stochastically rainfall. And not only that, but it can do it in the context of the seasonality of either your model. So as you march through time, through the months, it will be, you can, you have to go back to that model to see how it works, but essentially that model uses these inputs right here, and they're seasonal inputs. These can all be gathered by processing the time series records, obviously, except for the missing records, obviously, but you would get a pretty good sense of um, how the model operates over the seasons using this input right here. And so what this model does then, once it has that, then it goes through the Markov chain process, which is here. And there's only one change that I made to this model, and that is instead of saying, the way a Markov chain works is it says, if it's wet today, or if it was wet yesterday, then we're going to apply a probability number that's different than if it was dry yesterday. If it was dry yesterday, we use a lower, it's usually going to be a lower probability of it raining versus if it was wet yesterday, it's a higher probability. So that's the way that you can simulate these durations of storms that occur. And then these gaps between the storms is using these two different probabilities. That's the whole point of Markov chain. But regardless, what we do now is we say, oh, actually, we have a time series record that we're going off of, and we just look at the previous time series value. And if that one is a non-zero or above zero, that means it was wet. So that means we can come over here and we can say, okay, we're going to look at the previous days from the time series record and see if it was a wet day. If it was, then we'll use this probability. So that's just a little switch that I've made in the model, that instead of just being purely a stochastic model, it's being tied to the time series record, looking at the previous day. And so then it can make a smart, informed decision on what we can assume for the missing day that follows that day. That's what it's doing. So let me just run the model so you can kind of get a better sense of what I'm talking about. So here is the time history result, and there's kind of a lot going on here. Let me first of all show you the full picture. I'm going to change the y-axis. So here's the full picture of what this time series is. Kind of confusing, but what it does is it says, okay, we have an error code, a -99. That's what we're showing here in the red. There's a lot of errors you can see, but it looks worse than it really is. This is actually a really good data set. So you might not believe me right now, but if we zoom in, I'm just going to hold down the control key and zoom in here. If you zoom in, you can see that these missing records, or sorry, these error codes, these are not error code. These are not missing records. The records are there, but they're just an error code. So it's a little bit different scenario. But if we zoom in here, then what you can see is that the red line, it drops down to the -99. That means it's missing or it's gone. And then what we do is we fill in where that's gone with a new number. And in the case that we're looking at right here, because this point that I'm pointing at was dry, because it was dry on that day, then we're going to use the probability, the lower probability of it raining on the next day. And then in a case like over here, where it was wet on this day, on the next guess that we're going to put in, it will use the higher probability factor. In this case, it turned out that it assumed it was going to be 0 raining, but then on the next day it went up to be raining. And if you zoom in on a place where there might be more missing data, and there is a case in this data set, there is one period of time where it's missing a lot of data, and that's right over here. Let me zoom in. You can see I've got the red line behind the blue line, so that's why it looks like this kind of thick purple. Maybe it would be easier if I change this to dashed. Maybe that would make it a little bit easier to see the difference. Okay, so let me zoom in there again. Okay, maybe a little more. Okay, so you can see here that we've got time series records all the way up to, there's a few errors over here, but right here is where now we're missing everything. We don't have any record between 2000, early 2002 all the way until the end of 2003. So a little more than a year, like a year, more than a year and a half is missing. And so we just filled it in with a stochastic time series generator. But the nice thing about this is, yes, okay, these are random numbers that we're putting in, but they are random numbers based on the historic record already. So it's not going to put in just totally bogus information. On each month, it's going to be putting in values that are representative of what all the months of all the years that we've seen in this record. So it's an informed approximation um, of filling in missing records, which I think would be a lot more useful. And obviously, we'd want to be careful if we're missing much more than just this little point in time over the whole set. But one thing that's nice to do if you're dealing with something like this, when I go back here to reset the scale of this time history, then it shows all of this, which is kind of annoying. So what you can do is go here to the chart style and then go to the y-axis and then just change the minimum to 0. And that way it kind of makes all that stuff disappear. I did put symbols on my line for the missing data, so just to reduce the amount of green lines that are going to be going vertical up here to show this, because you can see I have missing data on the y2 axis. And really I was just showing that so that I could visualize and see myself, where are my missing values in this time series data set. So anyway, we could spot check around, we could go around to other places in here and look at what I've done at certain places for interpolating. So here you can see that we estimated some rain occurring right here when we had some missing records. Oh no, we assumed 0 right there. But anyway, we could walk through and we could look at all these places where we've made these assumptions, and this works pretty well. I think it would be definitely useful if you had to try to make sure that you're capturing all of your values at any points without making assumptions that are potentially overall making or perhaps a bad assumption. If we just said any missing records are going to be zeros, then in this particular model it would be problematic because of that year and a half that we're missing, right? But sometimes in those kind of cases you could just say, let's just copy, maybe we know that year was a dry year. We could just go find another dry year in the record and just splice it in there. There are things like that you could obviously do as well there. So it is true that my current implementation right here that we're looking at, it did not take into account that it didn't look at, we didn't put in there that, we need you to replace it with a dry year or a wet year. We just said, just randomly do it based on, generally what it's seen in the historic record. So it'd be more of an average is what it replaced it with. So there are some of those limitations there. Okay, so that's using that's stochastic imputation. Now let's look at another one. Okay, so this is a model where let's say you have a time series data set with very few points. And actually, I think I like the other. These are in our library online as well, by the way. But I kind of like this other one better. They do the same thing, but this one just is a little more interesting. Okay, so here is a data set. We have some observed data, and you can see here that they are happening at just not equal time durations between each. They're not regular intervals, is what I mean. So what we want to do is we want to see how those points compare to our model output. That would be useful for something like calibration. So here's a plot that shows those few points at non-regular intervals compared to our regular interval continuous output of our simulation. So this is something that comes up from time to time, and people ask, how can I easily show and compare my non-regular interval data to my continuous output? So it's kind of a trick. You have to do a trick, essentially, to do this. It's not that big of a trick. I mean, this is essentially it right here. But let me walk through what you have to do. So we have our, this is just kind of annoying me. We've got to reset that size. Okay, so we have our non-regular measured data here. And the important thing here is that you make it discrete change. That's important. That has to happen. So these are discrete measurements that we've put into this time series. Then what you do is you put those into an integrator. And the way that you put discrete changes into an integrator is through the discrete change input down here. So they go in there, and then what we have to do is make sure that we always reset it back to 0 again after we've recorded that value in the integrator. And the reason this goes into an integrator is not because we're integrating it over time. It's just the integrator can accept a discrete change and display the output, and you can use the output in your model continuously. So the integrator is a very powerful thing to deal with and accept and use discrete changes in your model. And in this case, we're going to just put it in there, gather the information, be able to have access to it, and then immediately remove it with this other discrete change. So this discrete change, what it does is it says, it's a little bit tricky, but we essentially say, okay, if the value has changed, then we want to put essentially the negative of the previous observed record, which essentially puts it to 0, or it's going to be the negative previous value plus the initial amount, which essentially allows us to, let me turn the line on so you can see. Kind of makes more sense when I turn this line on. And if I were to okay, so what we do then is, so we have this initial amount is -10. That's why you see this always going back down to -10. And that just allows us to hide the values that we don't have records on. So that's what the trick is. We're resetting the integrator down to a negative value to essentially hide it when the value is not being updated. And so it just stays down here and it's just hidden away until we get another discrete change from our time series, and then it records it and puts it up here and then back down again. So that's what's happening. So then if you just, that is the one drawback with this, is you have to force your axis to essentially hide those values and then turn off those lines. So then we turn this line off, and it's not a very common thing to do this. So I know it's probably seems like a lot of work to get this, but you can definitely go to our library and download this model and play with it yourself. But it does work pretty well. It gets the job done. And not only that, you could do an optimization in GoldSim in which you try to look at the difference between these measured values and your continuous point just at those times, and calculate those differences and take the root mean squared or whatever over time of these and try to minimize or maximize whichever one you're looking at. Like let's say it's an r squared, try to maximize your r squared and get these to line up better. So this would be a way that you could calibrate a model of your continuous output to try to match just at those times where you have records, try to match those lines up. But this is a way that would be common for displaying your discrete record values, where you have between these discrete times no information, and then just to be able to show only those. So I know I went through quite a bit of examples here, but that is the presentation. And like I said, I will be providing all of these models that I've been demonstrating in our archive when I post the recording. So those are some ways to deal with missing data in your time series in GoldSim. And that concludes the webinar, and I will be hanging around for another 5 or 10 minutes to see if there are any questions. But if not, thank you very much for joining this month, and hopefully we'll see you again next month.